Grace and peace to you all, and welcome back to my channel. This is Donald C. I'm an author of A Hidden Mathematical Genius Within Revealed. So today's question is on logarithms. Evaluate the following expressions. So to answer this type of questions, for now we only need two laws of logarithms. And the first law which we need to know or to remember is that when you have log of a and base of a, this should give us, so when you have a log, the value for the log and the base, if they are the same, then it means you're supposed to have a 1. So log of a base a is equal to 1. Then the other law is when you have log of, let's say we have log of b to the power x, then base a, this is equal to, so now what you do is this power can come down there. So this is equal to x log of b base a. So these are the two laws which we are going to apply in this particular question. Okay, so the first one is log of 10,000 base 10. Okay, so how do you work out this one? So we say log of 10,000 base 10. So what we can do here, first thing, we can try to make our log to be the same with the base. So here we have 10,000, and we want to make sure that this 10,000 is expressed in a form where it is 10 raised to the power something. Okay, some number. So how many times can we multiply 10 to get 10,000? Okay, yes, that's correct. That is 10 to the power 4. So 10 times 10 times 10 times 10 times 10 will get 10,000. So we are going to have log of, where there is 10,000, we put 10 to the power 4. So log of 10 to the power 4 base 10. Then according to our second law, which I mentioned, this one, the power can just go down there. So we have log of 10 to the power 4 base 10. This power will go down there. So we are going to have 4 log 10 base 10. Okay, so 4 log 10 base 10. And if look at here, log 10 base 10, we have the log and the base are the same, are equal. So it means log of 10 base 10, this one is a 1. So we are going to have 4 times 1, and we remain with just 4. So the answer there is 4. Okay. In the second question, we have log of 625 base 5. Okay, again the idea is the same. What you do is we need to express this 625 to be 5 raised to some power. So how many times can we multiply 5 to get 625? Okay, so 5 times 5 is 25. Times 5 you get 125. Times 5 again you get 625. So even this one is 4. So we are going to have 5 to the power 4. So 5 to the power 4 is 625. So we have log of 5 to the power 4 base 5. Okay, so now again we can bring down the power. So we are going to have 4 log of 5 base 5. Again, log of 5 base 5 is 1. 1 times 4, you get 4. Okay, the third one, we have log of 243 base 3. Again, the idea is the same. We need to express 243 to be 3 raised to some power. So how many times can we multiply 3 to get 243? Okay, so 3 times 3 is 9, times 3 you get 27. 27 times 3 you get 81. 81 multiplied by 3, I believe it will be 243. So it will be 3 to the power 5. Okay, so we are going to have log of, so where there is 243, we are going to have 3 to the power 5, then base 3. Then this power, we can bring it down there, so it will be 5 log of 3 base 3. Again, log of 3 base 3, this is a 1, since the log and the base are equal. Okay, so log of 3 base 3 is 1. 1 times 5, you get 5. So that is the answer. And the fourth one is log of 64 base 2. Again, here the idea is the same. We need to express 64 to be 2 raised to some power. So we are going to have log of, where there is 64 will be 2 raised to some power. How many times can we multiply 2 to get 64? It's 2 to the power 6. 2 to the power 6 is 64. That is 2 times 2 times 2 times 2 times 2 times 2. 6 times you get 64. So where there is 64, you put 2 to the power 6. So we are going to have log of 2 to the power 6 base 2. Again, this power can come down there, so it will be 6 log of 2 base 2. Again, log of 2 base 2, since the log and the base are equal, we'll get 1. And 1 multiplied by 6, you get 6. Okay, so that was number 4. Then number 5. Number 5, it's log of 1 over 32 base 2. So this one is a bit different. So what we do is, this 1 over 32, when you go back to the rules of indices, we know that when we have 1 over a, this 1 over a, to get rid of the 1 here, this is equal to a to the power negative 1. So when you bring the a upwards there to the numerator, the power will change. If the power is positive, it becomes negative. So here we had power 1. Okay, so that power 1, when you bring the term to the numerator, becomes a negative. So 1 over a is equal to a to the power negative 1. So here, where we have 1 over 32, it will be 32 to the power negative 1. So we are going to have log of 32 to the power negative 1, then the base of 2. Again, we need to make sure that we express this 32 to be 2 raised to some power. How many times can we multiply 2 to get 32? It's 5. So we are going to have log of, where there is 32, it will be 2 to the power 5. Now this is also power of negative 1. Then base 2. Okay. So now, When you have power of the power will multiply. Here we have power 5, and here there is power negative 1. So 5 multiplied by negative 1, you get negative 5. So you are going to have log of 2 to the power negative 5, then base 2. Again, the power will come down there. So we are going to have negative 5 log of 2 base 2. And again, we know that log of 2 base 2, this is just equal to 1, since the log and the base are equal. Okay, so log of 2 base 2, this is 1. And 1 multiplied by negative 5, you get negative 5. So this is how you go about it. So we have used just two laws of logarithms. The first one was log of a base a is equal to 1. If the log and the base are equal, then you just get a 1. Okay, and when you have a log of b to the power x base a, the power can go down. Okay, so we have log of b power x base a. This is equal to, the x will go down there, so it's just x log of b base a. Thank you so much for your time.